Statistics lesson 4.2, addition rule and multiplication rule. 3 objectives. Develop the ability to calculate the probability that in a single trial, some event A occurs and some event B occurs, or they both occur. Apply the addition rule by correctly adjusting for events that are not disjoint or overlapping. Develop the ability to calculate the probability of an event A occurring in the first trial and an event B occurring in the second trial. Apply the multiplication rule by adjusting for events that are not independent. Distinguish between independent events and dependent events. All right, so that's what we're going to do. Compound event or any event combining 2 or more simple events. So that's a compound event. The last section we only worked with simple events. Addition rule, the probability of event A or event B. Probability in a single trial, event A occurs or event B occurs, or they both occur. To find the probability of event A or event B, add the number of ways event A can occur and the number of ways event B can occur. But add in such a way that every outcome is counted only once. Probability of A or B is equal to that sum divided by the total number of outcomes in the sample space. And I'll show you a little bit more about what I'm talking about. Probability of event A or event B equals the probability of event A plus the probability of event B minus the probability of event A and event B, where probability of event A and B denotes the probability that both A and B both occur at the same time as an outcome of the trial procedure. All right, here is a little helpful tip. Helpful hint. When you see or, you should relate that to addition. All right, when you see or, relate that to addition. So here's an example. If one subject is randomly selected from 555 subjects given a drug test, find the probability of selecting a subject who has had a positive test result or uses drugs. So how are we going to write this? Let's see. Positive. Let's see. Positive test result or uses drugs. Now, if we follow the formal definition, probability of A, positive test results, that would be 70. All right, so we're going to follow it first. So we got 70, and then uses drugs. So subject uses drugs. That's 50. So let's see, 70 plus 50. And then the probability of A and B, the probability of A and B, that would be 45. So we're going to subtract 45 from that over 555. And that's going to equal 0.135. Now that's following following the formal definition. What if we wanted to do a more intuitive approach? Okay, a more intuitive approach. So we got the probability of A or B, and we found it equals 0.135 on the formal. So let's try the intuitive. It says find the probability of a subject of a subject who had a positive test result. So positive test result, let's see, we had 45 plus we had 25, and then a subject who uses drugs. Well, we got 5 here plus 5, and we divide that by 555, and again we get 0.135. Okay, you can try it in your calculator and see what you get. There we go. So both ways you get the same answer. Myself, I prefer to do the intuitive approach. That way I don't mess it up. Sometimes you will. It's easy to do. Disjoint. Mutually exclusive. If events A and B cannot occur at the same time, disjoint events do not overlap. Disjoint event. Let me give you an explanation. Disjoint events. Event A, randomly selecting someone who is male. Event B, randomly selecting someone who is female. The selected person cannot be both. Okay? Events that are not disjoint. Event A, selecting someone who is taking stats. Event B, randomly selecting someone who is female. The selected person can be both. So those are not disjoint. So that's kind of like an example. Let's see. Here is a summary of the key points to the addition rule. And let me write these. You probably need to put these in your notes. So let's see here. What do we got? To find probability of A or B, first associate, that's supposed to be an S, not an A. First associate the word or with addition. Put that in your notes. 2, to find the value of the probability of A or B. So to find the probability of A or B, add the number of ways, A can occur, and, well, let me spell that out, and the number of ways B can occur. But be careful. Be careful to add without, I didn't spell that very well, double counting. But without double counting. All right. Make sure that'd be good to put that in your notes. That's a little helpful reminder. Complementary events. The probability of A or event A or the complement of event A, and that's pronounced, let's see here, that's pronounced A, that's pronounced A bar, okay, equals the probability of event A plus the complement of the probability of event A equals 1. And with a little bit of algebra there, you get the probability of the complement of A equals 1 minus the probability of A. Or the probability of A equals 1 minus the probability of the complement of A. And we'll give you an example here. Based on a journal article, the probability of randomly selecting someone who has sleepwalked is 0.292. So the probability of sleepwalked is 0.292. If a person is randomly selected, find the probability of getting someone who has not sleepwalked. So the probability of A bar equals 1 minus the probability of A. We don't really know what, we're not told what not sleepwalked is, but we can infer it from 1 minus 0.292 because we know what sleepwalk. So either you sleepwalk or you didn't, and that's going to give us 0.708. All right, so that's how that works. Multiplication rule. Probability of A and B. The probability of event A and event B. The probability that event A occurs in the first trial and event B occurs in the second trial. Note, the notation probability of event A and event B has two meanings depending on its context. For the multiplication rule, probability of event A and event B denotes that event A occurs in one trial and event B occurs in another trial. For the addition rule, we use probability of A and B to denote that events A and B occur within the same trial. So how do you calculate probability of event A and event B? It equals the probability of event A times the probability of event B given A. Okay, so that bar means given. That means given. Given. All right. And some people, let's see here. Some people might read it as the probability of event B occurs after event A has already occurred or given. To find the probability that event A occurs in one trial and event B occurs in another trial, multiply the probability of event A by the probability of event B. Be sure that the probability of event B is found by assuming that event A has already occurred. Kind of tricky. Let's take a look at something else. Independent. Two events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. If A and B are not independent, they are said to be dependent. And this can apply to several events. And go back to the disjoint. Okay, if you're not sure, go back to the disjoint. Caution. Don't think that dependence of two events means that one is the direct cause of the other. For example, having a working light in your kitchen and having a working light in your bedroom are dependent events because they share the same power source. One of the lights may stop working for many reasons, but if one light is out, there is a higher probability that the other light will be out because they have a common electrical source, power source. So let's try one here. If two of the subjects who use drugs are randomly selected with replacement, and then we'll do a second one without replacement, So we'll call this one A, and we'll call that one B. Find the probability that the first person selected had a positive test result and the second selected person had a negative test result. So we're doing this with replacement. And by with replacement means after we pull the first name, we're going to put that one back in the hat, and it's just as an equal chance. Okay? So with replacement, positive test result, positive test result would be 45 over 50. All right, 45 over 50, because subject uses drugs. If two of the subjects were randomly selected with a replacement, find the probability the first has, and the second one has a negative test result. So that's going to be positive or probability of a negative test result. And that's going to be 5 over 50. Okay? So now we apply the multiplication rule. 45 over 50 times 5 over 50 equals 0.09. Okay? So that's A. That's A. Now, let's do the same thing, B, without replacement. So after we pull the first person, we don't put them back. Okay? So here we have P of positive test. That's going to be 45 over 50, just like before. Okay? But the negative test, probability of a negative test, is going to be slightly different. Okay? Because we've already pulled one, we no longer have 50, we now have 49. So that's going to be 5 over 49. So the probability of A and B, positive test result and negative test result, is going to be 45 over 50 times 5 over 49, which equals 0.0918. Okay, so it changes a little bit. We must adjust the probability of the second event to reflect the outcome of the first event. The first events, well, so hence that's why the equation is probability of A times the probability of B given A. That's why we have that, because without replacement, your population has decreased. Okay. Sampling with replacement, which is kind of what we just went over. Sampling with replacement, selections are independent events. Sampling without replacement, selections are dependent events. Treating dependent events as independent. 5% guideline for cumbersome calculations. How do you know? Okay. If you have a very large sample, or let me read this. When sampling without replacement and the sample size is no more than 5% of the size of the population, treat the selection as being independent, even though they are actually dependent. And we'll do an example. All right. Assume that 3 adults are randomly selected without replacement from 247,436,830 adults in the United States. Assume that 10% of the adults in the United States use drugs. Find the probability that the 3 selected adults all use drugs. All right, so let's do it. Now, I mean, in theory, you're not going to put that individual back in and and whatnot in theory. But we're going to treat it as the independent. Okay, so we're going to 10%. That's going to be 247,436,83 because we over 247,436,830. All right, that's our first one. And then our second one is going to be 24,743,682 because we took one away over 247,436,829 because again we took one away times, and then we're going to take another one away. So we got 24,743,681 over 247,436,600 or 828. Almost lost track there. All right. And that's going to be 0.123999. All right, so that's going to be that. Okay. Now, let's take a look. Suppose we just treated it as independent. Okay. The probability of someone using drugs was 0.1. So that would be 0.1 times 0.1, because that was 10%, right? Times 0.1, which equals 0.001. Okay? So what's the difference between those two? Okay? What is the difference? It's not very much, is it? And really, if you rounded this, if you rounded that, if you rounded it, it would be 0.001. Okay? So the difference is negligible. So we just so we follow this guideline, because I mean that would be 3 is not too bad, but what if you had to do 1,000 of them? Wouldn't that be kind of that would be, well, painful? Okay, I would be willing to bet most of you wouldn't do it. All right. I don't know what I just did there, but I hope it stops. It did. No. Now let's get rid of that. I don't know what I did, but I did something. All right. Let's look at the second example. When 2 different people are randomly selected from those in your class, find the indicated probability by assuming that birthdays occur on the days of the week with equal frequencies. Okay. Find the probability that the 2 people are born on the same day of the week. Well, it doesn't. So the first person is on any day of the week, right? All right, and then the second person being born on that same day would be, well, how many days of the week? That would be 1/7. Okay, so for A, we have a probability of 1/7. Now, find the probability that 2 people are born on Monday. Okay. Well, let's see. What's the probability of the first person being born on Monday? That would be 1/7. what's the probability of the second person? That would be 1 over 7, which gives you 1 over 49. Okay, you got to pay attention to the wording because it says here, find the probability that two people are born on the same day of the week. Well, the first person, does it matter what day? It doesn't. So that is a probability of 1 over 1 times 1 over 7, which gives you 1 over 7. Okay? Because, well, I mean, you might say it's 7 over 7, right? Anyway. Example, modern aircraft are now highly reliable. And one design feature contribution to that reliability is the use of redundancy, whereby critical components are duplicated so that if one fails, the other will work. For example, the Airbus 310 twin-engine airliner has 3 independent hydraulic systems. So if any one system fails, full flight control is maintained with another functioning system. For this example, we will assume that for a typical flight, the probability of a hydraulic system failure is 0.002. All right. If the Airbus 310 were to have one hydraulic system, what is the probability that aircraft's flight control would work for a flight? Well, that would be right here, okay? The probability of hydraulic system, let's see here. Let's see, would work. So does not fail would be 1 minus the probability that it fails. 1 minus the probability that it fails, which would be 1 minus 0.002, and that's 0.998. Okay? Now, given the Airbus actually has 3 independent hydraulic systems, what is the probability that on a typical flight, control can be maintained with a working hydraulic system? Well, let's see here. So first off, we're going to have to take this 0.002 and multiply it 2 more times. And what do we get? Okay, we're going to get equals 0.0008. Okay. Now this is scientific notation. Okay. 8.e to the negative 9 means you're going to have 8 zeros in front of that 8. All right. So here we go. So this is going to be the probability does not fail is going to be 1 minus the probability that it fails, which is going to be 1 minus and that's going to equal, let's see, 1, 2, 3, 4, 5, 6, 9, 2, I believe. All right, and there we go. How do we interpret that? With 3 independent hydraulic systems, there is only a 0.000008% probability that flight controls cannot be maintained because all three systems fail. Tree diagram. Pop quiz. True or false? A pound of feathers is heavier than a pound of gold. Question 2. By a small sample, we may judge the whole piece. I'll give you just a second here. All right. Well, let's see, what is the probability that you actually got it right? All right. Now, let's see here. We're going to do it. First, we're going to do a tree diagram. That's what that's all about. All right. I don't know why I did that. Well, anyway, so here we go. First question is either true or false, right? Now, the second question can be A, B, C, D, or E. And then we have A, B, C, D, or E. So let's connect these. So what's the sample space? Well, here we got 2, right? And then here we got 5 in each one. So, and that gives us 10, right? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there is only one correct answer. So that would be the probability of, how do we say this? Right and right? Yeah, the probability of right and, or correct and right, I'll just use right, is 1 over 10. So here is the beauty of the multiplication rule, okay? So the probability of both correct would be, well, what's the probability of the first one? 1/2 times the probability of the second, 1/5, which gives you 1/10. Now, wasn't too complicated on this one here because the first one was 2 and the second one was 5, but it could get complicated real quick, okay? It could get complicated real quick. And let's see here. One more thing I want to do real quick is do a little summary here. Addition rule for probability of, well, the multiplication rule. The multiplication, let's see here. The addition rule, probability of A or B, associate that with A. Probability of A and B, associate that with multiply. All right. The word and for 2 trials suggests multiplication. And when multiplying A and B, we must be sure that the probability of event B takes into account the previous occurrence of event A. All right. Good job, folks. Thank you very much. See you tomorrow in class.